Hello, good evening, students. We'll start in about 5 minutes. Okay, so let's start. Um, our agenda for today is simple. We have done 9 days of learning. Good evening to all. We will revise everything that we have done in the 9 days. Okay. So that is our 10th day to consolidate the 2 weeks of learning. The day one, when we checked what all things are possible in AI ML, what are the high level things. Day two, when we did Python. Day three, we did Python. Day four, we did Python. Day five, six, seven, eight, nine, we did more of machine learning, SQL, and all these things. So, one by one, we will review all the concepts and obviously all your questions that are there. So I already see Ishwar asking what are the arithmetic operators involved, what are the statements are involved, what are the keywords. So one by one, we will tackle all of these things. Okay, because I've been observing there have been a lot of questions from different groups on different areas. So while we revise all the 9 days, we will be able to cater to all the questions that come to your mind, right? Okay. So this was our day one discussion, right? We discussed some use cases in terms of uh, uh, yes, SQL operations. Raghu will come to all the questions as soon as we reach Python, and we will tackle them. So day one was AI ML in business, right? As to where AI ML is getting applied. So product design, co-pilot, sales prediction, customer analysis, analytics on web, network security, cyber security, the data life cycle, the data mining patterns, warehouses, insights and predictions, many such things. So with each of these things, let's also see Chat GPT. So in parallel, we will do that also. Explain business applications of AIM. Because this was asked a lot by students that tell me the real world application. Explain business applications of AIML, right? So customer service, obviously, a lot of customer service chatbots that you see on insurance, banking, and other websites, they run using AIML. Marketing, so these are three of the most heavily used use cases for AI/ML, right? Customer service in terms of chatbots and human interaction, marketing in terms of digital marketing campaigns and demographics and all that analysis, sales to qualify and identify lead, risk management, fraud detection is also a very heavy use case in terms of AI/ML. So I'll give you the simplest example, right? You have a trend where you specifically use your card, debit or credit or banking in specific areas, geographies, or shops or stores. Suddenly, if a transaction happens in a third party country, then that is a red flag, and AI/ML can catch it based on patterns, right? So that way, this is another list which exists. So customer service, sales and marketing, fraud detection, predictive maintenance, again, a heavy use case where all the power plants, industries, manufacturing, they try to predict what is the maintenance that might be required. Supply chain optimization, another area. NITI does a lot of work in Mumbai on this area. Risk assessment and fraud prevention, healthcare and medicine, natural language processing, like as in the search engines that we have, process automation, financial analysis and trading. So these are all good examples of um, AIML, right? Let's switch to our presentation again, right? So I hope use cases are clear. We won't spend so much time here. Now, this is one more slide that was not there the day we had discussed, if you remember, the first day. But I have kind of added it today, a few days back. Data science process. So we discussed about it, right? Data collection and types, patterns, data quality, data treatment, EDA, which is exploratory data analysis, data mining, and so on. These are some of the things we should be aware of. Also, we will see one more thing on Chat GPT, which I've been talking a lot, but we haven't researched, which is explain differences, or let's just say explain AIML, data science, and analytics. Okay, because we hear all the three terms a lot. So see, AIML we have already studied. It stands for artificial intelligence and machine learning. Data science is a multidisciplinary field that combines scientific methods, algorithm systems to extract knowledge and insight from structured and unstructured data. I will explain what is structured and unstructured data in a minute. Analytics, on the other hand, is the systematic exploration and interpretation to gain insights and support decision making, right? So that's one thing we need to be aware of in terms of what are the things. Why I keep telling you these things is because data science and analytics are closely related to AI/ML, as they heavily rely on AI and machine learning techniques to extract valuable insights. That is the reason from day one, I've not been teaching you AI/ML in isolation. I've been teaching it to you with the words and concepts from data science and analytics. Analytics is the third step. AI/ML is the basic algorithms and the neural networks and so on. Data science is the study of structured and unstructured data to find out your for scientific analysis, and analytics is used to support decision making based on the interpretation of data, right? And so on. Now here also we will see similar things. Third one is extracting insights and so on. Now that we talk of data science, we also should be aware of as to what is structured and unstructured data. Structured, textual, what are all these data types which exist, right? We did discuss data types little bit, but let's also see a bit more of it, right? I hope now that you have gone through some of the algorithms, all these things are making more sense, right? Yes. So what is structured and unstructured data? We did not discuss it. Let's see it. We will keep this sheet for structured, this for semi-structured, and this one for unstructured content, right? Structured content is exactly like this sheet, two-dimensional at times, row and column format. Suppose I'm collecting student information, roll number, name, email, phone, uh, address, gender, grades, degrees. When we collect information like this in an Excel sheet, two-dimensional format, that is structured content. Semi-structured content is XML and JSON, which I briefly discussed, right? They work via tags. So XMLs work via tags and JSON works via key value pairs, right? So that is how these work. You can also have other formats for semi-structured content. Basically, it is structured, but in a different form. Unstructured, on the other side, could be videos, it could be music, it could be Word documents, it could be PDFs, and so on. All three types of content have different types of treatment. Obviously, unstructured content, you will use natural language processing, you will use video analysis, codecs, and so on. Semi-structured, you have specific libraries for it for the treatment. Um, and structured, obviously, we have seen CSVs and Excel sheets and so on, right? So this is one concept we need to be aware of. Let's also ask Bard, how does it classify these concepts? Explain structured versus semi-structured versus unstructured data. It's taking time. See, structured content, product inventory data, financial data, customer records in a database, two-dimensional Excel sheet. Then semi-structured content, XML, JSON, HTML documents. HTML is like this view that we have, correct? And then obviously unstructured data, which is emails, social media posts, images, audios, videos, and so on, right? And you also have um, uh, comparative table here. Let's see this one as well. Very similar, right? It explains, but it doesn't give you a table, but it's good, right? Both of them are explaining the same concept. So I hope this data type concept is clear to everyone. Can I get a quick thumbs up in terms of those who have understood? So something additional we are discussing today. Good. So your data science process goes through all of these things. Data collection and types, patterns, data quality, data treatment. At different points of time, we have discussed many of these things, right? Data collection using surveys, the types that are there. I gave you one classification, other classification was in the blog that I had shared, right? From which I had picked up from Wikipedia and enhanced. Then we have patterns, we have data quality issues, which we were fixing. We discussed about data treatment and so on. Then we discussed, so students keep sending your questions based on all the confusions that might have happened in the 9 days in your mind, in case, or there are residual questions. As I finish each slide, a slide deck, 9 days, I will answer as much as possible. Okay. Now, AI, ML, and neural networks. So, AI, if you remember, was the superset where we had the search problems, state space problems, reasoning, cognition, and all such capabilities were being discussed since more than 60, 70, 80 years, right? Or whatever the exact number of days it is. Then machine learning was a subset where we saw regression. We have seen some amount of ensemble decision trees. We have seen a priori and so on. We will also see going forward some of the other uh, machine learning algorithms. Then there was neural network, which was replication of human or animal mind or brain, and it had more cognition and reasoning capabilities compared to these algorithms, the simpler ones, right? We discussed that. Then we discussed types of AI, various classifications. So narrower the problem is, the easier it is to build a solution, obviously, right? Wider the domain, the more problematic or more effort is required. LLMs, ChatGPT, and so on. We also discussed briefly what is supervised, unsupervised, and reinforcement learning. Supervised is labeled data, unsupervised is unlabeled data. Reinforcement learning was using rewards and punishments. Then we discussed about the neural networks, replication of animal brains. We discussed about neurons and their perceptrons and with various types of functions like switches, sigmoid, and so on. We discussed about the patterns that they form and how do we train them at a high level, right? I agree. Then we looked at what all you should be learning. Now, this is a partial list, right? This is not a complete list, but you should be learning calculus, statistics, also linear algebra, and then along with it, some of these products and tools like Anaconda, SAS, Tableau, and so on, right? So that will give you a good start to learn, correct? Then we saw the Google Colab, Anaconda, and RStudio overview. Naim also exists. I didn't show it. AI around us is what we discussed, chatbots and chat GPT and digital assistants and so on, right? Now, this was one area where a lot of questions keep coming every day. Many people ask me, um, uh, many people ask me that, sir, what I should pick up right now. What you should pick up is something that is known to you. I always tell all the students that I teach that uh, don't go for something that somebody tells you. You go based on your analysis and what uh, um, your capabilities are and what the market demands are, right? Take a mix of both because you know yourself best whether you will be able to fit into a data engineer role or a data scientist role or data analyst role or similar roles. You will have to pick up. There are obviously more things also, right? But at a high level, data engineer is where a lot of IT related work happens, information technology related. Data scientist is where functional plus technical plus IT plus a lot of mathematics. Data analyst is more of functional role where domain and business related things happen. But you also need to know some amount of statistics also there. I haven't added linear algebra here, but calculus, statistics, and linear algebra you should learn all three, at least to intermediate level, right? I generally will tell you the pros and cons. This is very demanding area in terms of data scientist role. Data engineer is what most of the IT people do. Like when I will set up Python, I will set up SageMaker, I'll set up cloud, I will set up all the models, I will help the data scientist in tuning it, I will set up a big data environment and so on, right? So this is something which is the most popular. This is relatively more difficult. And this one is more for slightly people who are more from management background. They generally prefer these kind of roles. So you need to pick and choose what is your capability and what you would want to do, right? Then we discussed history of AI, which I'm not going to repeat. It simply evolved from formal reasoning right up till neural networks, expert systems, and finally deep learning, big data, cloud, and so on, right? So that was our day one. That was there in maybe 10 minutes now. Now, next topic that we took up was Python, and there are a lot of residual questions. So let's pick that up and sort out all your questions one by one. So from day two, we started with Python, if you remember. Uh, we discussed all the Google Colab, Anaconda Navigator. I also showed you Replit. We discussed bit of truth table and its logic, and slowly I presume you would have understood why I explained that to you. Truth table and its logic, variables and objects, data types, operators, loops and conditionals, indentations, strings, keywords, inputs, functions. We discussed all these things, and all the code that I have put it in that file and given to you. There was additional code also which was given later. That also I have provided to Amar. And in case anything is missed from videos, you can always ask me and I will give it to Amar to upload, right? We discuss these concepts. Let's quickly discuss and then go to the questions that were there. And we will also ask Chat GPT the same thing. First was truth table, where we discussed and, or, not, and all those things. We discussed variables and objects in terms of how variables are implicitly data typed, which is called as dynamic data typing. We discussed about data types. We discussed about operators, mathematical and others. We discussed if else, and so on. We discussed about for and while, the auto updation, and so on. We discussed about indentation, why it is important for each block. Strings, which were immutable, if you remember, all of you. Keywords, which we cannot reuse. They are used by the language itself. And input box, we discussed about typecasting there. Then we discussed functions, right? I think, discussed even, odd, prime number and all such examples. Correct? Now let's see your questions. I will ask Chat GPT and then I will also obviously explain to you. So first question is, what are the arithmetic operators involved in Python? What are the statements and keywords? So statements and keywords. Let me ask Chat GPT one by one and I will explain in parallel to you. Right? Please give a list of keywords in Python. Let's also ask please give a list of operators in Python. So here are the keywords. Here is a list of keywords in Python. False, class, finally, is, return, try, lambda, for, continue. Which all did we see? We saw true, false, and as, del, which is delete, define, continue we haven't seen, class we haven't seen, for we have seen, try we have seen, if we have seen, import we have seen, else and else if we have seen. I think these are the ones, or not. These are the ones we have seen, while and return, right? We have seen all these examples of keywords in Python. Now here are our operators which somebody was asking me, right? So there is arithmetic operators which has addition, subtraction, multiplication, division, modulus, and exponentiation. We have comparison of operators which are equal to, not equal to, greater than, less than, greater than or equal to, logical operators which is and or not. We have bitwise operators. I haven't discussed bitwise operators, but you convert decimal into binary. And once you convert decimal into binary, you can use bitwise operators to do bitwise operations onto your binary values, right? Obviously, you do it directly also, it's okay, but this is slightly more complicated. We also need time to explain how do you convert between, let's say, decimal to octal, octal to binary, decimal to hexadecimal, and all such conversions are there, right? In and not in, identity operators, and so on, right? The ones you need to focus on are the first three: arithmetic, comparison, and logical operators. They will be useful to you. Bitwise, if you are very interested and keen, you can practice and experiment with it, right? And then these are the keywords. Keywords are reserved words which we cannot use. In the sense we can use, but we cannot use for any purpose other than what has been earmarked by the language. Got it? That is what is a keyword. They have a specific meaning in the language, and these are the operators to do all the mathematical and other things on it, right? Okay, that was the first question. Second is, what are the SQL operations involved? So SQL is done using a library, right? We looked at SQLite, if I remember correctly. Did we look at SQLite together? Yes, no? Yes, I think we looked at SQLite together, right? So SQL, let me put it in a different way. Please list SQL libraries in Python. So see, SQLite is what we used, where we used a built-in lightweight database, and with it, you can use MySQL connector Python, this PsychoPG, which is for Postgres. You can use PyODBC, which is for Oracle, Sybase, and MySQL, Microsoft SQL Server, SQL Alchemy, which is for a few other databases in the list, and so on. So depending on which library and which database you are using, you will use and work with SQL, but your concepts will stay the same. I discussed SQL with you. Your CRUD operations stay the same: create, read, update, delete, and all such things, right? So your CRUD operations, your queries that we saw from W3 school and so on, across all of these remain same. There might be minor differences in how they operate, but more or less the thing is the same. Okay, got that? Does that answer your questions, Raghu and no, Raghu mainly, right? No matter which database you use, there will be 90% similarity in SQL, only 10% differences. An interesting area to see, which I haven't taught you, is um, list the execution order of SQL statements. So, see something very interesting which I was reading, that the SQL execution happens this way. First, they run from, then join, then where, then group by, having, select, order by, limit. It is important so that we can write good types of queries, right? What is getting executed first? What is getting executed last, right? So that what you do is you don't put, if you can do something from, or you can do a join early, you do that rather than pushing things like when you are putting it in a nested form and so on. So those are some things which we need to be aware of in terms of how to use, when to use, and so on, right? So that's just one thing. I haven't taught this to you, and many of these words are also not very clear in terms of you, because matlab to you, because you might not have discussed these with me, but you can explore SQL from the same link that I have provided to you, right? Okay, let's go to day 3. So day three was this. We did some revision of the initial Python concepts, variables, keywords, operators, indentation, comments, conditionals, loops. From there, we moved on to the Bing videos that I had provided, but we didn't run them. Then I explained file handling, right? I explained to you the commands that are there for file handling and so on. Then we discussed Python SQLite on Geeks for Geeks, which we just now discussed about. Data types which are there in Python, casting for the input example that I was giving you. Then learn the Python programming, the overall link that I've been using for most of the work. And then slowly we moved on to descriptive statistics, if you remember. So do you want me to discuss the files again, or you want me to move ahead? What is the suggestion? Should I open the files once and just quickly browse through them and let you ask any questions you might have? Can I get a thumbs up if that's something you all want? Okay. Just give me 1 minute till it loads. Okay, it has loaded. So we'll quickly do the revision as requested, right? I think the examples that we discussed were Python files, decision statements and loops, exception handling, exercise 1, matplotlib, operators and expressions, lists, Seaborn, tuples, sets, and dictionaries, and so on. So let's quickly see them. Let's start with exercise 1. This is where we discussed about all the concepts of variables, if, else, and so on, right? And comments and all the things printing and so on. Then obviously we discussed operators and expressions where we had the print x plus y, these were the operators and so on. The other types of operators which respond to us with true or false. We discussed about shortcuts for updating values. We discussed about true and false in terms of it being a keyword, and or and not. We discussed about if else, then if else if, or single if, all such things and comments and so on. All these things we discussed. Then I showed you the matplotlib. So whatever is getting done, I will close it so that that gets done. This is also a good file which I did not discuss fully, but a simple file to start your work with. Then we discussed matplotlib and all the plots that it can do for us based on equations. We discussed that NumPy is also there, and matplotlib is also there in our examples, and various equations we are creating, legends we are creating, multiple plots we are doing. All such examples we discussed: annotations, bar plot, scatter plot, area plot, pie chart, and so on. All these things we plotted there. Then, if you remember, we moved on to lists, or before that, we actually moved to decision statements and loops, where we discussed about after if and all this, we discussed equal to and double equal to difference. And from there, we moved on to the nested if. If you remember this example that we had discussed, if I less than 15, I less than 12, and so on. And from there, we moved on to the data types discussion, where we discuss float, integer, character, or string, and so on. And slowly we move towards while and for. While you need to update. Then I showed you how do you have nested loops. Somebody asked about a triangle, and I said yes. Then we printed it using some other example in the next day. And then we saw the nested loops and so on and how to debug them, right? Then we discussed about Python files, and in Python files, we discussed about uh, all this file open. How do you open the file? It has its own modes for write, read, append, and so on. I didn't discuss R plus and so on, but basically, at least we discussed the read, write, and append mode for opening a file. And from there, we also discussed about aliasing and opening the file, giving it a specific name. Exception handling we saw in terms of division by zero and how do you handle all this gracefully. And obviously we saw lists, tuples, and dictionaries and sets. Lists are much more flexible. Tuples are also flexible, but they are immutable. Sets are related to the set theory that we studied, and dictionaries were related to custom key value pairs that we create, especially the keys, right? So we discussed all these examples in the next 3 days, which were there, right? I also discussed briefly about the concept of iterator and so on. Then we just briefly looked at Seaborn, what type of plots it can do for us and so on. And I explained about heat maps and correlation and so on. Slowly, I started to introduce you all to machine learning, right? That was our discussion. No, no. So Suvarna asks, is it necessary to give please word while giving prompt? No. By the way, uh, there are some very good prompt engineering courses. So let me show that to you. Was my screen visible or paused at that point of time? Did I not? No. Okay. 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 Let me open it again. Sorry for that. So this is what I was discussing one by one the files. Let me discuss again. It will take 5 minutes. Some more energy, but we'll do that. Decision statements, exception handling, matplotlib, operators and expressions, files, lists, cbon. We also discussed strings and tuple sets and dictionaries. So this is what I was saying, that this was the initial part where we discussed all the variables, operators, and so on. If you remember this file, we discussed it briefly. Then we moved on to obviously decision statements, if, and so on, all these examples that were there. And slowly we moved on to for, while, debugging it, nested for, nested while. We discussed many such examples, exception handling. How do you handle exceptions gracefully? Matplotlib in terms of plotting various types of graphs here from mathematical equations. That is what we saw. Annotations, local minima, maxima, all such things we discussed, scatter plot, area plot, pie chart. Then this was another file we had used where we discussed if else and all such examples and commenting. This was the files related examples where we used the three modes: write, read, and append. These were those files. Then we discussed about lists. As I said, lists are very flexible and they are mutable, whereas tuple is also flexible but not mutable. It is immutable. Sets are related to set theory, right? And lastly, dictionary as custom keys that we can create. We discussed all these examples there. Um, Python strings also we discussed in terms of immutability. We almost went till the end in terms of formatting and so on. All those examples we checked. Then we discussed about Seaborn, where advanced charting and plotting can happen. We discussed a bit about it, heat maps and all these plots which are there. So all these files are there in the day 2 or 3. I don't know whether it is day 2 or day 3, but they are there. All of these files we one by one discussed. We also discussed about tokenizer, right? All these things we had discussed. Then what did we miss? I did not discuss classes because that needs another OOP discussion. Excel also, yes, we discussed Excel. I told you the 3-step process for Excel sheet, how to work with it. Open the workbook, load it, make the sheet active, work, and then save, right? That was the steps that I had told you. And we created updated an Excel sheet as well. So that was our day 3 and 4. Okay, in terms of Python. Now let me see what all questions are asked. So which statistics are considered as Python, Raghu? Actually, the question is unclear, but I've got what you're saying. All type of statistics almost can be achieved using Python. So if you remember the other day, we opened, let me open again. Hold on. I'll open the same thing that we had done the other day. Yes, same one. So if you remember, explain statistics and its major areas. We asked this to Bard as well as ChatGPT, and it gave us 10 major areas, right? So most of those areas, either via library or some other way we can do, but there are more powerful tools. R is better suited for statistics, and SAS, SPSS and such tools are even better suited. But I will not say that Python should not be used for statistics. I'm just saying that probably there are better tools as well. So descriptive statistics, inferential statistics, hypothesis testing and all, probability, data mining, machine learning areas, right? This also will give us some 10 areas that we had asked the other day. Time series analysis, multivariate analysis, Bayesian statistics, and so on, right? You can do most of these using some or the other library in Python. That is possible. It is not as if it is not possible, but there are better tools. Okay, Rakhi, I will tell about each class introduction, some introduction of class in very short if possible. Rakhi, can you explain more over chat as to what do you mean by introduction? You mean introduction of each day or how is it? Right? Uh, just explain to me more. Now, yes, yes. So prompt engineering. I'm going there. I'm going there. Somebody jumped in with that. So if you type prompt engineering, this is the latest thing in generative AI. It is the new field which is emerging in terms of how do you talk to um, generative AI kind of an system, right? How do you talk to it? What all kind of things it can do for you and so on, right? So if you look at it, there are many, many tutorials and things that have been coming up, right? So this is some tutorial which is there. I've found some very good ones on LinkedIn actually. So let's see what they are saying. Let's see for the official one from Microsoft, right? So non-chat scenarios, system message, few short learning, start with clear instructions, repeat instructions, prime the output. So these are all ways of doing better prompting, right? Prompt engineering means when I go to this place, how should I ask questions? How should I follow up? Let's ask it. Explain prompting for BART. And let's ask this one, explain prompting for chat GPT. Let's see what it says. Be as specific as possible. Use keywords and phrases which are relevant. Please provide examples. Be patient. Some of the examples for prompt: write a poem about any topic, write a blog post about the latest trends, write a short story, write a song, write a script. Bard is still under development. That is fine, right? Now, here, what does it say? So, this is basically how do you ask questions? Um, how do you ask questions in terms of um, um, uh, the Bard and Chat GPT? And there is a full line of area that is getting developed for it. So, that is where text to image, um, and many things that are happening, right? If you go to LinkedIn, you will also find some courses on prompt engineering. So let me show you. I cannot run it obviously. um, so see this: introduction to point prompt engineering for generative AI. There is a course for it from people, right? So prompt engineering, chat GPT, few short learning, and so on, right? Fine tune. How do you do that? Obviously, for copyright reasons, I cannot run the course here. But it's an evolving area in terms of what all is happening in terms of how do you interact with these chat GPT, Bard, and such systems, Azure, and so on. How is AI used to fetch resumes? So they search for keywords, they search for LinkedIn, they search for many things and then analyze. And based on that, they do things. So let's ask, how is AI used to shortlist resumes? Resume parsing is done, keyword matching is done, skills and experience assessment is done, contextual analysis is done, performance analytics are done. So all these areas using AI ML is happening. Let's see in BARD. Keyword matching, skills assessment, text analysis, and machine learning. Got it? So that's what we get here. Okay, the way we have what we have done. Okay, okay. So if you want me to explain that way, I will explain. Okay, let me do that. Okay, like we did for bread example for uh, a priori, right? Okay, let me open that. So let's create a resume in front of you. Let me know once my screen is visible. Give me a thumbs up. Okay. So see, name ABC, email abc@a.com, um, phone number, address. Sometimes we write, sometimes we don't write city, introduction, skills, details of project, achievements, degrees, or let's say education, and so on, right? So, what AI does for us, all these systems, there are also links to your LinkedIn, right? So, what AI will do is it will parse through all of this. And first thing it will do is find out the keywords. Like, suppose you want to work in AI ML, it will check whether prompt, chat, GPT, Java, Python, such things exist or not. Then it can go and parse the projects and see what kind of projects you have done, what kind of skills you have, achievements that you have achieved, and so on, right? So, one is textual analysis, as they were saying, other is keyword analysis, right? Then, obviously, contextual, which means which company you are working in, what is your LinkedIn profile, your activity there, and so on. There are hundreds of things that we can do for resume analysis, but basically keywords, text, context, LinkedIn, public posts, um, your articles, journal entries, blogs, many such things we can check, right? Right? So all such things we can analyze using various techniques. Your techniques could be natural language processing. It could be naive Bayes for keyword analysis. It could be neural networks. It could be and so on, right? So many such techniques we can use to do all this analysis on a CV. You got my point? Parsing means Meghna going through the whole CV, word by word. Got it? Okay. Okay. Let's go back to our BARD and other things. Okay. Then what did we do? We started with descriptive statistics. So let's see the descriptive statistics file here. Somewhere it will be there. Hello. Yeah. So my voice is audible? Yeah. So with statistics, we saw initially how do you create lists? What was a markdown? Then we discussed mean median mode. Then we discussed about how do you treat missing values with this mean median mode. We also discussed about how do you treat fractions for the same. Then we discussed about the measures of we discussed about variance, standard deviation, and all those formulas, right? All those things we discussed. We briefly discussed about normal distribution. And from there, we moved on to that one good article on tests, various types of hypothesis testing. And then we moved on to regression, right? We did all those things. Let's open the regression file also. Just give me a second. This one we discussed. Multiple regression we discussed. Regression we discussed. We also discussed a bit of clustering. We also discussed NumPy and pandas, by the way. Yes. And correct. So we discussed NumPy and pandas also because that was also asked by some of the students. In NumPy and pandas, we discussed about creating arrays, then treating those arrays in terms of the functions that can be run on top of it, sum, multiplication, its data types, addition, and all such things we had learned. Then later part, we looked at some of the copy array and subtract and all those things, dot product and all. I told you, right? These are internal functions for mathematics that it has built into the library. Then we discussed about panel data, as somebody told me, or pandas. We created the data frame objects from this, also from the internet. And we did locate function, we did read CSV, we did working with Excel. Then here drop and all these functions we saw, right? In terms of adding something, I told you about what happens when you write something on the left side versus the right side and so on. So all those things we had discussed, if you remember. Does everybody remember? Yes. Right? So with that, we'll quickly take a 6-7 minute break. Then when I come back, we will revise a priori, regression, multiple regression, decision tree, and I will tell you about random forest, and then we will close the day. Okay? Okay. So it is about 8 p.m. Let's meet again at 8 p.m. in 7 to 8 minutes. Okay? Yeah. Hello, students. We'll start in a minute. Let's first see the remaining PPTs, day 3, day 4. Day 5, Nambai and Pandas I have discussed. Let's go to day 6. Okay, so students, this was our day 7 when we started with regression after Python, right? So we discussed the home loan and example where we discussed about uh, all the factors which were the independent variables sort of, and from there the dependent variable in terms of y is equal to mx plus c, or y is equal to m1 x1 plus m2 x2 plus m3 x3 and so on plus c. Somebody also discussed about the error which was right. I told you about following these people which were there: Andrew NG, Venkatraman, Yan Lee Kun, all these people. We discussed in the Excel sheet the home loan example where we had the loan ID, we had uh, um the income, co-applicant income, CIBIL score, and so on. And we discussed how regression can be applied there, which was logistic regression. We also discussed about simple linear regression and multiple linear regression, right? This was that link that I had given to you, how to select the best, or not the best, but the right statistical test. There was a flow chart also given in it. So let's go to our examples. I also discussed about the data analysis process. I gave you this blog link to follow to understand the data analysis process. Let's go and see our regression example. So this was our regression example, right? I explained that we have all these points. We want to draw an approximate line through it so that we can make predictions, right? We had one function called as estimation of the coefficients. And from there, we drew the regression line and finally the function for it, right? Here we have mostly used only matplotlib, and we have written the formulas for calculating all the things manually, right? Then I showed you how do you do the same thing using a model, right? Multiple linear regression using sklearn, right? Sklearn is a library where we can take the linear model, and we loaded the Boston data set which was there. If you remember, the pollution, how big the house is, whether the people, how much people are earning, and all such data was there in the Boston data set. We did the test train split of 60/40, and we ran the linear regression. We used the model, we did fitting, and finally from there we got all the coefficients for M1, M2, X3, M3, and so on. M1, M2, M3, M4, M5, M6, and 7, 8, 9, 10, 11, 12. Right? We got all those things and plotted residual errors. The important thing is to know these 12, so that y is equal to m1 x1, our answer comes, and whatever new value comes, we are able to at least understand where it will lie and so on. Right? All such things we kind of did um, in normal regression and multiple regression. This file was more of calculating everything manually in terms of the things. If you remember, estimate coefficient and plot regression lines both are mathematical functions that we have written inside these. Whereas this one is where we are using a library called as ExcelR and doing things using it, using the Boston data set, right? This was our data set, and this was all the explanation that I was trying to do with all of you. This should be actually marked down, right? So this is marked down. Then we discussed about a priori. In a priori, we also have other links which are there, but I am not opening them again and again, from linear regression and all those things that I have shared with you, right? Then we discussed about a priori, which is where we had a data set like this. I first explained to you from the uh, data set in terms of how we buy things and the examples that I gave you about 3 or 4 people or families. From there, we moved on and talked about this data set, which is from European Union at that point of time, United Kingdom, Sweden, France, and so on. And we discussed about the invoice date, unit price, customer ID. We saw that one customer ID with an invoice date, which is the same, and customer ID is same, and this is same. That means all those things are bought together at that point of time. If you remember, it was taking a lot of time to load also because it had, I think, 5 lakh entries or whatever the case may be, right? That's what we did. And then from there, um, in a priori, we first created um the country-wise basket by breaking things out of it. Then we did hot and cold, which is basically converting the categorical variables into 0 or 1. Here they did it for x is less than 0, return 0. If x is greater than 1, return 1, which means all those values they created converted into 0 and 1, which we discussed, right? It is for betterment of the model, how to run it. Then we got the frequent items, which is of interest to us, right? The interest of us was what are the frequent items that are bought singularly or in combinations and so on. And what we did extra is we converted both of those to CSV here. And then we opened the CSV also here, right? Then we discussed briefly about decision trees. I told you about the iris data set, which had um 3 or 4 types of flowers, and then you build a decision tree out of it by breaking at different points. We discussed about the Gini coefficient, the gain, and all. Here we discussed about support, lift, and confidence, the 3 concepts. So that was all of our discussion in terms of these models, in terms of uh, machine learning. Out of a priori, frequent data sets is something of interest to us. Per country, we found that out because we broke the basket into UK, Sweden, and France. So for all the 3 countries, we had different CSVs which we created, right? And that's what we did. We also, I think, discussed clustering. Clustering was so by now we have discussed simple linear regression, clustering with the elbow method. We have discussed multiple linear regression, a priori, and we have discussed a bit of decision tree. I also showed some things to you uh, in the uh, uh, R programming module, right? So let's do one thing now. Let's one by one search all these algorithms that we have discussed in our AI/ML model and see what questions we can ask it, right? So let's see one by one. Explain below algorithms. Simple linear regression. We will read through it to multiple. Let's put here explain k-means clustering. See, simple linear regression is a statistical method used to draw a straight line to model relationship between two variables and so on, right? There is a code snippet also that we looked at it. Multiple linear regression is a statistical method to model relationship between a dependent variable and multiple independent variables, right? So that is the thing that we did. Why? So they sometimes write it this way. It kind of looks confusing, but to me, y is equal to mx plus c looks a lot easier. And this one is k-means clustering. If you remember, I explained via the diagram uh, that when you form clusters, you randomly assign the centroid and then it moves. It tries to find the closest items in the cluster and then form the right circle or the cluster and so on. We saw those examples in terms of clustering, right? So this is simple linear regression. This is k-means clustering. Then we discussed association mining. Right? Then what else did we discuss? Explain decision trees. Let's also ask it an intelligent question. Explain which machine learning algorithm to use in which scenario. This is something important you should be looking at. Let's discuss that also if it can answer. Otherwise, we will use Google. There are some very good notes on this. Explain which machine learning algorithm to use in which scenario. See, this is something you should note. Please note this question because this might lead to a lot of interview questions that might be important for you, right? Which is the algorithm that you should be using for which type of a problem? So let's read one by one once it prints. So see, choosing the appropriate machine learning algorithm for a scenario depends on the nature of problem, data available, the desired output, resources and constraints, and so on. Linear regression, when the target variable is continuous and the relationship between the features and the target can be modeled as a linear equation. Logistic regression for binary classification problems, when the target variable is categorical, right? And the relationship to be modeled is using the uh, uh, logistic function. Decision trees suitable for both classification and regression tasks. They are intuitive methods that can handle numerical and categorical features. Random forest, it is built from multiple decision trees to improve its accuracy, which means you have one decision tree here, one here, one here. You join the results of all three together and do things. Support vector machine. Or let me read and then we'll see the diagrams also. Useful for binary classification problems with a clear margin of separation. Naive Bayes, it is a probabilistic classifier. This is used a lot in document classification based on keywords. like see text classification, spam filtering. Somebody asked me about resumes, right? So Naive Bayes is a good way to probably filter resumes also. K nearest neighbor is another one for classification and regression, neural networks, clustering algorithms, gradient boosting that combine weak learners sequentially to build a better model. Now let's see the diagrams for it. Next, machine, you just type this machine learning and then go to images section. Let's type one by one. Regression. So see, diagram. Okay, diagram. Now see clustering. This will explain everything to you. Clustering. You see this diagram, all of you, right? Now let's type which other one was I discussing? Decision tree. Decision trees, right? Let's see random forest. See random forest, multiple trees, and the output from it is used to make it better. See three trees, three trees, three trees, making it better. Let's see ensemble methods. I don't know if there will be diagram for it or not. Let's see. Yes, so ensemble is see different types. Neural network, decision tree. We are mixing all of them together to get output. Mixing in the sense not together, but their outputs. Then let me show you one more. SVM, support vector machine. See, hyperplanes are being drawn. Let me see a good diagram. Wait. Here. Right? With these diagrams, you are able to see support vector machine. Bagging and boosting. Let's see if we can see. Yes, weak learners, outputs, strong learning. See this boosting. See the diagrams. I always learn it by two ways, three, four ways. So let me tell you my tricks, right? How I learn, and you can do the same thing. One is obviously diagrams. Second is the equations. Third is the concepts, right? So these three things, if you are aware of, your problem is resolved, right? Always try to build diagrams in your mind, write equations, think of the concepts and keywords. That's it. If you can remember these four things, especially the diagram and the concepts and keywords, a lot of your problem is resolved. Let's also ask it, explain naive Bayes. This is also very interesting for spam and text classification. Let's also ask ChatGPT. That can be used for both classification and these works by assuming the features of a data point are independent. This means the probability of this by spam and so on. So what it does is, like suppose I am seeing this article, right? It will start checking all the uh, type of words that are there in it and then calculate probabilities and start classifying. So if you feed a new document, it will compare to the old probabilities and see if it is a similar type of a document to classify whether it is spam or not spam or one type of document or other type of document and so on. List some algorithms in line base. I think I have used one of these. If I can recall the name, just give me 1 minute. One of these I have used. Uh, there is one library from a university. Anyways, so we don't want to go there. Uh, Bagging and boosting, again, parallel and sequential. See the diagrams. That is what is going to tell you a lot of things. Okay. So I think um that is your revision for today. Next 10-15 minutes, we will take some questions and then we will close. Satish cannot hear me. Is it? Is my is are others able to hear me clearly? Yes. Okay. Okay. Um, I will also tell you some good places to learn the mathematics, right? So two courses that I very recently attended, LinkedIn Learning Linear Algebra. So machine learning foundations course is very good. Obviously, as I said, I cannot run it, but I can show it to you. This one is there. Machine learning foundations, linear algebra. Then there is one for calculus. Linear algebra I'm still working on, but calculus I have completed. Right. So this one is also very good. Um, then there is statistics. So all such courses you can attend either from LinkedIn Learning, Coursera, or Udemy, and so on. They will be very helpful, right? So these three areas. Is my voice breaking, friends, or no? Is everybody able to? My LinkedIn ID, people are asking. I don't know, Amar, is it okay to share or how is it? I'll let you know. I'll share by Amar. Okay. So last 10-15 minutes, let's go with questions. I've given you, okay, or I forgot to give you one diagram, right? Neural network, the most important. Let's also discuss the types of neural networks. So see, this is how neural networks look before I throw it open to questions. These are all the layers, neurons. There is back propagation. There is all doing the fine tuning, right? Then you can also type to see types. So there are so many types of neural networks. This one is the famous diagram, right? So all these are different types of neural networks. Like convolution neural networks are used for image processing. Generative AI is used for language models, um, and so on. ANN, CNN, and many types are there. So that is also something you need to be aware of, right? In terms of neural networks, a longer debate. This is a short course, but all such things do exist, right? Again, diagrams you can see. See this one. Let's see the image processing one. See, it's a almost a 1 hour discussion to explain how it does image processing, but there is an image. You break it down into multiple uh, parts, the this starts forming, then there is an output. This is the classification that is done, and so on, right? So that is your CNN, convolution neural network, which is there, a famous type of one, which processes images, if I remember correctly, right? Again, this is also very interesting area. You can do that on Google Colab also. Let me show you an example. Google Colab, CNN neural network example, Python. I've run multiple of those. You can, so what do you do there is You connect your Google Drive with this and add the images there and then process it, right? Okay. So that is there. Computer vision is something I have not discussed, but that's fine. Uh, I think for today we will stop here and let you ask questions. Is my voice low for others? You can search me on LinkedIn, Neil Harvani. My name is there, right? You can add me, but do keep the sanctity of ExcelR because I'm teaching via them. I've pinged you my name. I'm available as Neil H or Neil 27. It would be best if you route your requests through ExcelR. What is PEP 8 conditions? If I remember it correctly, that is for formatting. Let's just find it out. Just give me 1 minute. Python PEP 8, I think it was the um, guidelines and best practices. Yes, that's what I said. Formatting and how to write good code, right? Basically, these are coding standards. So that's a good discussion that you have triggered, right? How do you write good code? So there is very similar to this. You have Java coding standards. So these are coding standards for um, all the languages which exist, right? So this one is for Python. In terms of naming styles, how do you choose names, tabs versus spaces, block comments, and so on. All languages have their own, what do you call, coding standards. And that is what is PEP 8. Got it? What could be the ultimate AI is what Ganga Reddy is asking me. Um, So Ganga Reddy, I think we are already neural networks is something which is good, very good. Only thing is it requires a lot of energy in terms of electricity and lot of large uh, uh, computing power. So if somehow we can have a model which can use lesser amount of electricity and complexity and do similar kind of work, that would be the ultimate AI as per me, because we are very close to uh, animal brain right now, right? So that probably is the next step. Can you explain types of AI again, sir? So there is the larger superset. Okay, so let's also see that by the diagram. Okay, AI, ML, DL, Venn diagram, exactly. So it's like this. Many people do it one way, other people do it that way, but basically it's like this. See, artificial intelligence is the superset: search problems, state space problems, cognition, reasoning, logic, and all such things. Machine learning are the algorithms that we saw. Deep learning is done using neural network, and data science overlaps with this. And you have analytics out of it for decision making. Think of it like this. Got it? Suvarna? And Muni, I think I answered your question on PEP8 conditions in Python, right? Okay. So Any other questions? Just give me 1 minute. I am sharing my LinkedIn ID. Wait. This is my LinkedIn ID. Got it, everyone? Welcome. Any other questions? Teaches the math behind machine and deep learning courses. So there are three areas. I have found two good courses. So you have to learn three areas: calculus, you have to learn linear algebra, and you have to learn statistics. All three are available on LinkedIn Learning, Coursera, edX, uh, Swayam, which is Indian government UGC portal, and such. You might want to start with Swayam UGC. I hope it is called Swayam, right? Just give me 1 minute. Yes, Swayam NPTEL is also a good place to start mathematics. So for free, yes, Swayam is very, very cheap. I think any course you want to do will not be more than a few thousand rupees. And free courses also. Okay, so the best free material that I have seen is Khan Academy, as per me. You can try Khan Academy, free mathematics. Just see this. See all this. I have already bookmarked. So linear algebra, differential equations, calculus, multivariate calculus, pre-calculus, statistics and probability, all these things, see all math is totally free here, as far as I know. Does that help you? I'm going to put this here into the chat. Got it? So you can use this site. let's just click one area and see. See, like this, they will have free things. Are you able to see on my screen? Let's see differential calculus. Like this. I'll just click on anything. Got it? So I'll give you a longer list. Khan Academy, try this first. Then try NPTEL Swayam. Then try Coursera, edX, and try LinkedIn Learning. 2, 3 are free, 2, 3 are go. Android app development, again, there are hundreds of resources. Online IIT courses, there are so many good ones on NPTEL Swayam from IIT. Yes, we'll try to create a chatbot at the end of the course. Okay, so any other questions? There are many good courses from BITS Pilani and IITs. There is a bachelor's degree in data science from IIT Madras that you can do with your engineering or BSc. They run a very good course there. With your work, you can do from BITS Pilani. There is Manipal, Mahe. So many are there now, online courses. And obviously platforms like ExcelR, which are teaching you so many things, right? So all that is there. Yes, Kuldeep. Okay, so I will hand it over to Amar if there are no more questions. So, Nikhil, to answer your question, some of them are more on skills. The one you are mentioning, Udemy, is more on skills. Some are more on concepts. So it depends. What is your aim, right? XLR also is giving you very good skills, I believe. So you need to make a choice or attend both as per your requirement. I'll stop here. Amar, you can take over.
Yeah, sure. Thank you so much.
Thank you.
Oh, guys, please mark your attendance. Tirnath is already shared with you. Tirnath, can you please share once again in Zoom and
Yeah,
YouTube?
sure, Amar. I will answer.
Yeah, thank you.
Shared, Amar.
Okay, sure. You can wait for some time, then you can wind up.
Okay.
Guys, don't worry about the certifications. We'll explain you all the things in the last session, okay? Guys, tomorrow we don't have session. Our next session is on Monday. Srivada, you will get the recorded sessions on LMS. So please visit the LMS. And if you're facing any difficulty while accessing the LMS now, please drop an email to edl@excelr.com. Our team will check. Sir, how much percent attendance is necessary? So guys, for certifications, 60% attendance is mandatory to get the certificate. Prem Kumar, I'm saying that please wait for some time. We'll explain regarding the certificate in the last session, okay? Yeah, Hemavanti, we already all the material in the LMS. So please visit LMS. You will get the all material and record. Himavanti, we are done with the 10 days. 5 more days to go, okay? It means I didn't get. Can you elaborate, please? Himavanti, you are facing difficult, and then I'm sharing my mobile number with you. Please drop an WhatsApp message. So I think you have lots of questions. So I will suggest you for that. So Hershey is
I
asking
will.
when the class will end. So Hershey, we are done with the 10 days and 5 more days to go. So 26 is the last day of the session, like next Friday. Prem is asking like how we can know our attendance percent. So Prem, you only know that how many session you attended and how many attendance you marks. Still, if you want to know from our side, then please drop an email to edl@excelr.com. Our team will check you and update you. Okay. Yes, Neil, you are saying something?
Can I log off now?
Yeah. Thank you so much.
Thank you. Thank you.
Yeah.
Thank you all. Good night. Best wishes.
Guys, anything else? Yeah, shall we wind up the session?
Yes, Samar, we can wind up.
Okay. Thank you. Bye, guys.